I'm James Desjardins, EEG technologist at the Lifespan Development Research Center at Brock University and high-performance computing consultant with the SHARCNet HPC Consortium of Compute Canada. This presentation is a demonstration of the software extensions for EEGLAB that I'm developing for implementation with high-performance computing resources. In this demonstration, we'll be showing how to submit jobs of signal processing in EEGLAB to remote computing clusters. The cluster that I'll be using is the Hound cluster at sharcnet.ca. Basically, the environment that I'm working in is a local instance of MATLAB 2012B on a System 76 laptop out of the box with Linux Ubuntu 14.04, and then a couple softwares installed like free SSHFS and MELD. On the cluster side, there's Octave 3.8.1, which will be running the MATLAB scripts, as well as a compiled version of Amica 14 to be executed as MPI across cores. And this demonstration is really just about how to execute these procedures efficiently from the graphical user interface of EEGLAB. Now, when moving analysis from a local workstation to HPC resources, there's a few things that have to be taken care of. There's, the fundamentals of just being able to submit jobs to a scheduler versus executing them serially on the local workstation, but also dealing with a change in scale of the research. So new issues with file management, having data in multiple locations that are accessible to the compute nodes, perhaps a lot more data to work with, but also issues of provenance and annotation, so keeping track of everything that's happened in the sort of unsupervised execution on the clusters, and perhaps just a lot more things being executed because of the efficiency of the compute, and thus a bigger demand on being able to annotate properties of the data that were calculated. So in this demonstration, we're going to be talking about the software tools for transitioning from a local workstation use of EEGLAB onto a high-performance computing cluster and the efficiencies that come with that. But it's also important to think about if these tools are designed properly, they will house the framework for developing a repository of shared and co-developed optimized procedures that can be used across labs for neuroscience research. So to get started, here's EEGLAB, and there's basically two extensions. The main one is the batch context extension, which allows you to execute scripts generated from the EEG history field, or just to execute binaries that are developed, such as the Amica binary. So as an overview, I'll just go to the batch menu and run a history template batch. And here we see this is the interface that allows you to submit jobs, either to execute locally as a batch or on a remote cluster. And basically what you want to do is you want to load a series of data files. And on this series of data files, you want to execute some history file. Now, a history file can be a series of commands to execute in MATLAB or Octave, or it can actually be a call to a binary to execute outside of MATLAB or Octave altogether. So in the most basic form, you can then just execute these serially on your local computer and it'll go through all the files one after another. Or if you have access to a cluster, you can change the batch configurations. Now, first of all, there are settings in here that can change the way that each script is executed, but also you can change the properties of how it will run on a cluster. And then the other level is the actual context configuration. This is a definition of locations of the remote cluster. For example, where the remote execution host is, where some of the work directories are, and other sort of places that the computer will need to know about in order to run them on remote compute facilities. So I'm just going to go through each one of these things. So first of all, there's the data. The next thing is, what are these scripts that you want to execute? So I'll close this for now. And here's an example of a formatted script. So in order to really be able to run these scripts and be able to change the properties based on a data set, there has to be a formatted way of storing calls to MATLAB or to Octave. So this is basically just a text file holding a an instance of a modified EEG history, where there's a load function, and then there are these swapping strings, so square brackets with a string inside. This is basically information that can get swapped out at runtime. So MATLAB will read this text file, it will look for this square bracket with batch DFN, and then it'll swap in the actual current data file name that it's going to execute. And then there can be other things included in these square brackets with strings inside. For example, here's low bound hertz, which is actually a variable describing how that filter is going to run. What's the lower bound of the filter? And then for writing the output file, you can actually change the name. For example, looking for underscores and then removing part of that string and adding another part, so that you can change input-output names and run it systematically across files. So this is an example of a script that's going to run in MATLAB functions, but it can also just execute a binary. For example, execute Amica 14 with a specified input parameter file. Now, the next step is the batch configurations. So the scripts are what is going to run. The batch configurations are properties of how it will run. So if I go to File, Batch Configuration, what I can do is I can load objects that correspond to all of the scripts that I'm going to run. So in this example, I'm actually going to run 5 scripts on multiple data files. I think something like 8 data files in this example. So for each of the 5 scripts that I want to run, I'm going to load a configuration. So I'm going to Analysis, Support, Config, and here are the 5 configuration files. Open. Now a configuration file, you can see here, I have 5 of them. This holds the information of how it's going to run. The execute function is basically the function of how it's going to execute. In this case, it's the EF-SQ sub. SQ sub is the submitting function on SHARCNet systems. Now, this means that this job will be submitted to that system, and there's the replace string. The replace string is a bunch of variables that it will swap into the script. For example, the in path is this folder. This string will get swapped in to this field in the script at runtime. And then you can see all these other variables, and there can be as many of these defined as you want. And then you have the actual some execution specifics, such as the QSub options. If I click on the QSub options, these are properties that we'll be giving to the submit function, and the definition of all the possible inputs comes up in the display at the bottom here. So the order of this configuration is number 1. That means that this is the job that will run first. If we look at the next one, it's listed as order 2.1. That means that this one will run second, but then if we look at the subsequent Amicas, so this is another instance of running Amica, this is 2.2. That means that both of these jobs will be submitted at the same time. So this job will be submitted on the completion, or asked to run at the completion of the first one. This one will also be asked to start at the completion of the first one, as well as the third one. So we'll have 3 Amicas running simultaneously, and these will be submitted as MPI jobs across 4 cores each. Now, the last one will be submitted as order 3, which means that it will start on the completion of each of the second order jobs. So all 3 Amicas have to finish first before this concatenate function will start. and this is going to be executed in Octave, and Octave is going to be started with the traditional flags, which makes it the most MATLAB compatible. So once we have the batch configurations in and modified to run how we want them to, we can hit OK, and then the next thing is the context configuration. The context configuration is a set of properties that hold information about the addresses and locations of important resources for the execution of the job. So what I'll do is I'll say load context config, analysis support config, context, and then here we see that the remote execution host is hound.sharcnet.ca, and I am the user. And then we have other locations like the remote project archive and the remote project work. So the work directory is basically a file system that it can be accessed by the compute, where you want to keep files very temporary in there, and then there's an archive space where we can kind of accumulate the files for this data set. Now it can also hold system commands in here. Now you can define as many of these as you want, and what this allows you to do is submit commands to the system on a Linux computer for execution. And I'll show you a couple examples of this. So if I bring this down here and I select the SSHFS, which is mounting software, and I want to mount the archive, it populates this string with the variables that I have defined in the object, and if I click System, we can see that it will have mounted my remote archive space to this folder that I have in my current MATLAB folder. Now I can also mount the work directory that has compute access there, and then I can also hold functions like meld and compare the three directories. So if I click here, System, I can get basically this window right here, which is a directory comparison of my local analysis folder for this study, the archive space over on the cluster, and I can see here that all my raw data files are in the archive but not on my local computer. And then this is the work directory on the compute, so I don't need any of the raw files. I really just need the input files for the functions that I'm going to run, and that's what we see here. These are basically the input files to the computation that I'm going to execute in this demonstration. And then they'll be output to this empty preprop folder. So this resource allows us to keep track and actually compare files within these folders and do efficient transferring of the data. So once the context is set up, I'm going to hit OK, and then I can go back over here, go to File, I'm going to batch, and I'm going to run a history template batch. Now whenever this window comes back up, we can see that it's already populated with all of the batch configurations, that the context configuration is populated, and now what I'm going to do is I'm going to pick the corresponding history files, history support scripts, starting with the scalp art for artifact detection. I'm going to run 3 simultaneous MPI amicas, and then the last one I'm going to concatenate the files all back together as an Octave execution again. So hit OK, then these scripts will go sequentially, and then I'll do them in parallel across a bunch of different files. So from here I'm going to navigate right over to the work directory on the remote cluster, analysis, data, the init files. I'm going to pick these set files. Okay. So the way that it's set up right now, whenever I hit OK, each one of these files is going to be the input to each of these scripts, and each submitted as its own job. So they'll start as soon as resources are available. Then each of the subsequent scripts will get executed, submitted as jobs, and will start at the termination of the first one, etc., etc., etc. Now, command open, I'll just hit OK. So in the command line we can see basically for the first script, because it's running in octave, it generates an M file for each one of the data files from the history file. Then it generates a submit script, and then those are all transferred over to the cluster and then executed. And then we can see here the job IDs being returned. And then for the Amica jobs, only a submit script is generated, sent to the cluster, and then it's returning the job IDs. So what we can see now is it's gone through, this is the first script, the first Amica, second Amica, third Amica, and then here's the submissions for the last concatenate script to be executed in MATLAB with these M files. So what I can do now is the submission is finished. I can open a new terminal, and then I will go to cluster, so secure shell in to pound. So on here I can then ask for the jobs that are currently in my queue, and then we can see right here the jobs that I just submitted. So those are the first instances. A few of them are already running on Hound 11, and then the last 4 are queued and ready to go. Each of these octave jobs is running serial on 1 core. Here's the first instance of the Amica. Each one is set to queue on 4 cores when it's ready as an MPI. This star queue means that it's waiting for the termination of this job. And then here are the other 2 instances of Amica. All of these will be ready to run on the completion of the first ones. And then once the Amicas are done, then these will start executing. Now, since some of them have already started, what we can do is right from within MATLAB we can actually navigate down, and then we can see that in the log is where the information about these submissions is stored. So for each script, a folder is generated that houses the M file for each file. So basically the history file is turned into an M file after populating the fields. That's saved, and then it's zipped into a zip file, sent over to the cluster, extracted, and then this submit script is executed. And then we can see here that it loads specific modules for Octave and then submits these SQ jobs. Now, what we can do is that since this one has already started, we can take a look at the log. Now the log is holding the diary in the Octave command line while it's executing on the cluster. So we can check on the actual, advancement of this. So at the time that this last wrote, it was just loading that data file. And then we can check on any of these on the way. And then once the job is done, it just toggles through all of these things. Now, it's important to note that not only will this basically increase the execute speed, where basically now we're going to be running artifact detection, 3 Amica executions plus concatenation on multiple data files, basically in the time that it would take to do artifact detection, and a single Amica on 1 data file. Of course, you'd have to add on file transfer times and queue wait times. But also this folder containing the scripts and the configurations is all that we would need to form a repository for sharing this procedure, so that really anyone can then just take this folder, put their own data into it, modify the context to reflect their compute resource remotely, modify the batch configurations to run the scripts the way that they want, and then be able to execute it at the same speed. And that's an overview of the development of the batch context plugins for integrating EEGLAB with HPC resources.